The uncoded mystery on how the different planets that we see today were formed. So, what are planets? Scientists spent a lot of time arguing over what a planet actually is. In 2006, they came up with a definition. They said a planet must do three things. The first thing might seem obvious. It has to orbit around a sun. Second, it must be big enough to have enough gravity to force it into a spherical shape. And third, it must be big enough that its gravity cleared away any other objects of a similar size near its orbit around the sun. So, what about planets in other places? This definition is very much focused on our own solar system. But there are also planets in places that are not our solar system. These planets are called exoplanets. They can be found circling around stars, just like the planets here in our own solar system. What are dwarf planets? Dwarf planets are round in shape and orbit the Sun just like the eight major planets. But unlike planets, dwarf planets are not able to clear their orbital path, so there is no similar objects at roughly the same distance from the Sun. A dwarf planet is much smaller than a planet, smaller even than Earth's moon, but it is not a moon. The first five recognized dwarf planets are Ceres, Pluto, Eris, Makemake, and Huomia, and they are all uniquely mysterious. The birth of the Sun. 5 billion years ago, a giant cloud floated in one of the spiral arms of the Milky Way galaxy. This cloud, called as nebula by astronomers, was made up of dust and gas, mostly hydrogen and helium, with a small percentage of heavier atoms. These heavier atoms had been formed earlier in the history of the universe when other stars aged and died. This cloud began to contract, collapsing in on itself. The atoms, once separated, began to jostle each other, generating heat. In the rising heat, the atoms collided more frequently and more violently. Eventually, they reached a temperature at which the protons at the center of the atoms began to fuse in a process called nuclear fusion. As they did, a tiny bit of matter transformed into a whole lot of energy and a star was born. In this way, our sun came into being. The birth of the planets. The material in the nebula, not absorbed into the sun, swirled around it into a flat disk of dust and gas. Held in orbit by the sun's gravity, this disk is called an accretion disk. Materials in the disk accumulated by further accretion. Each planet began as microscopic grains of dust in the accretion disk. The atoms and molecules began to stick together or accrete into larger particles. By gentle collisions, some grains built up into balls and then into objects a mile in diameter, called planetesimals. These objects were big enough to attract others by gravity rather than by chance. If the collisions of planetesimals occurred at high speeds, they could shatter the objects. But when impacts were gentle enough, the objects combined and grew. For some 10 to 100 million years, these protoplanets orbited the Sun, some in egg-shaped circuits that resulted in more frequent collisions. Worlds collided, combined, and evolved for a dramatic period of time. When it was over, there remained 8 stable planets that had swept their orbits clean. A planet is defined as a body that orbits the Sun, is massive enough for its own gravity to make it spherical, and has cleaned its neighborhood of smaller objects. In 2007, researchers at the University of California, Davis determined that our solar system was fully formed at 4.568 billion years ago. They did this by determining the age of stony materials from the asteroid belt. The Sun sent out energy and particles in a steady stream, called stellar winds. These winds proved so strong that they blew off most of the gases of the 4 planets closest to the Sun, leaving them smaller, with only their rocks and metals intact. That's why they are called rocky or terrestrial planets. The 4 outer planets were so far from the Sun that its winds could not blow away their ice and gases. They remained gaseous, with only a small rocky core. Between the inner and outer planets lies an area filled with millions of asteroids, small, rocky, icy, and metallic bodies left over from the formation of the solar system. No planet were formed in this area. Astronomers theorize that Jupiter's gravity influenced this region so much that no large planet could take shape. Jupiter is 11 times the size in diameter of Earth and more than twice as big as all the other planets combined. It is almost large enough to have become a star. Of the 4 rocky planets, Mercury is the smallest, about 2/5 the size of Earth. Earth and Venus are almost the same size, while Mars is about half their size. Astronomers speculate that a smaller object must have hit Mercury, vaporizing its crust and leaving only the larger than usual iron core. Conditions on Earth. When the rocky planets first formed, they were largely melted rock. Over hundreds of millions of years, they slowly cooled. Eventually, Mercury and Mars, because they are small, solidified and became rigid all the way to their centers. Only on Earth and possibly on Venus, conditions remained in an in-between state. Earth has stayed partially molten, its crust is solid rock, and its mantle is rigid. But over geologic time, the mantle flows slowly, and the center of Earth consists of a solid iron core rotating in hot liquid called magma. The Earth's moon. At first, the moon orbited much closer to Earth. It has been moving away at a rate of almost 2 inches per year. The moon significantly affects conditions on Earth. The impact that produced the moon tilted Earth on its axis. This causes Earth's seasonal variations in temperature, since the side tilted towards the sun for one half the year's journey around the sun receives more direct sunlight. Also, the moon's gravity causes the ocean's tides, reduces the earth's wobble, which helps stabilize climate and slows the spin of the earth. Thank you.